Okay, folks, we're going to get started here. Hopefully everybody can hear me. So this is the last topic to cover with the live stream. So this will be the last live stream. Again, during this, if you have questions, you can send me something in the live chat, or you can send me a message via Edsby or via email, and I will be checking those throughout this. There's only 4 questions in this section, but we can definitely look at more if you guys want to. So the first thing I want to do is just take a look at reviewing the different content from the chapter. So the last 2 sections were on trigonometry, looking at right triangles, and then looking at non-right triangles and their formulas. This section here just has us apply all those things together. And depending on who you end up as a teacher for grade 11 maths, there's a good chance that you're going to start with some of this trigonometry as you're working through some of that initial content, which involves applying it to a circular type of problem. So right triangles, again, since at least grade 9, you've been looking at the Pythagorean Theorem, a squared plus b squared equals c squared. Again, the c is always the hypotenuse. And then you have the other two sides, a and b. In the case where you have an angle given on top of the right angle, what you have then is the hypotenuse staying the same, but the a and b sides now get named something different. The side opposite or across from that angle is the opposite side, and the side touching it that's not the hypotenuse is called the adjacent side. So you have the adjacent side here. So the hypotenuse and the adjacent side are adjacent to the angle, the hypotenuse being the special one, adjacent side because it has the right angle pointing at it, and then the opposite side is again across from the angle. And so in those cases, if you're working with that angle, you're working with trying to find those sides or find that angle, then you're working with the sine, cosine, and tangent ratios, or the trigonometric ratios as they're properly termed. So the trigonometric ratios are when we're specifically looking at the comparing the sides, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And again, that's where you could pull out that handy sheet to look those up as you're doing calculations, or using your calculator, making sure, again, you're not in radian mode. If you are dealing with non-right triangles, then we move into the sine law and the cosine law. So in a non-right triangle, whatever the angles are labeled as, we use capital letters, and then the opposite sides are labeled with a lowercase of that same letter. So if this is angle A, then the opposite side would be side A, and the same in each of the cases. So then you can either use the sine law or cosine law to solve these. How do you know when? If you just try and fill in a formula and you don't have enough information, then you can pick the other formula. But in general, the sine law requires you to have a pair of angles and their opposite sides. So it could be something like angle A and side A, angle B and side B. So you have to have a pair of angles and their opposite sides that you're working with. In the case of the cosine law, when you're working with that, you either have, in the case of trying to find a side, so if we were trying to find side A in the cosine law, then what we need to know to find side A is two sides and the angle in between. So the cosine law works when you have two sides and the angle that's in between them, or an angle that's adjacent to both sides. A is adjacent to both of those sides in this case. And so you have that. Or if you're looking for an angle, then you need to have all 3 sides. So you have 3 sides and an angle contained in between the 2 sides that are not related to, that are adjacent to the angle for that. So those are all the formulas that are applicable when we're working with trigonometric type of questions. The Pythagorean Theorem, sine, cosine, and tangent are used for right triangles. Non-right triangles will pull out the sine law or cosine law. Do note that the sine law does happen to work in right triangles, and it's only because the sine of 90 degrees is 1, and so it kind of makes it a moot point in the calculation, and so it does work, but best practice is to use sine, cosine, and tangent ratios, and then use the sine and cosine laws for the non-right triangles. So the questions we had were 4, 6, 7, and 8 out of the textbook there, and so we're going to take a look at all 4 of them. One of the big parts here is kind of getting the setup of these questions, and if you make sure that you get your setup of the question right, then you're usually in good shape if you're comfortable with picking your formulas. And you may need to use one or more formulas. You might need to use right angle formulas and then non-right angle formulas, just depending on the specific situation that you're dealing with. So in the case of number 4 here, what we have is a plane flying with an altitude of 1.5 kilometers above the ground there, and it's kind of at this point it's over a crater, and this might be something used in photography to determine sizes. They want to find the width of the crater, so using the altitude and the angles that maybe 2 cameras are pointing at. And if you've ever seen the 3D pictures, I believe they use them in geography class still, and you can use the special 3D glasses, and you can take the 2 pictures and merge them into a 3D image. This is how they take them. 2 cameras set up on the bottom of that plane. So if the cameras are set up at these angles, 68 degrees of a decline from the back, and then 56 degrees of a decline from the front, 1.5 kilometers above the ground, we can figure out the size of this crater. And so if we look at that, I've drawn a little diagram here in my notes. So there's our diagram. Now the triangle we're working with, we don't have any interior angle information as of yet, and we don't have any of the actual side lengths of this big triangle. What we do have is information about this this height here, the one side in both triangles at the 90-degree angle. But if we're looking at this distance across here, I'm thinking that a good resource would be to use the cosine law. I can determine this angle here. I can determine this angle here by subtracting them from 90, and then I can find the hypotenuse of the triangles. And this is something with these questions. There's multiple ways of doing it. Or we can just find these 2 interior angles and then use the opposite and adjacent sides and use the tan to find both of those. That's probably the quickest way. But if you, depending on what you see when you do it, there's a fastest way to do it, and then there's probably 2 or 3 ways to solve any of these. We're going to do it the fastest way, most efficient. So we're going to use some setups here where we take this triangle, and I'm just going to draw them quickly separately so you can easily see them. So there's that first triangle, right angle, it's 1.5. And then this angle in here, from here to here, is 90, because that's a horizontal angle, and that is a vertical angle. Horizontal to vertical, sorry. So we got 68 degrees, and then we have the remainder to 90, and the remainder to 90 is going to be 22. So we have a 22-degree angle in this triangle, 1.5, and we're looking for x. And in the other instance, we have the same 1.5 as the height. We're looking for that x. There's a right angle. And then this angle in here is the 56, and then the remainder up to 90. And so we do 90 and take away 56, and that's going to give us our 34 degrees for that one. So I have 2 triangles. I can use, if I label them, this is the opposite side, this is the adjacent side, this is the opposite side and adjacent side. I'm just going to use the tan formula twice. So I'm going to have tan of 22 equals the opposite over the adjacent. And then the other one's going to be tan 34 equals the opposite over the adjacent. So the only difference between these two is going to be the actual tan ratio that we use. And then again, you can use your table of values that I provided, or you can use your calculator and type in tan 22. As long as it's in degree mode, you should get a result of 0.3746 equals x over 1.5, and then we just need to move the 1.5 up and multiply it, so we have 1.5 times 0.3746, and that's going to give us 5.6 kilometers as our x. So this side is 5.6, and then we'll find this other side to finish this off. So tan 34, again looking that up, I'm going to get an answer 5.5592 equals x over 1.5. And again, same thing, we're going to just multiply that 1.5 by that 0.5592, and that's going to give us 0.8388. And I messed that other one up. I must have hit the... Yes, I forgot the decimal. It is 0.56. Would have been 19. So I missed the decimal place there in my multiplication. So those are the two distances. And then to find the total x there, total distance across, I guess that would be x1 and x2, if I was to label this properly. That total distance across x equals 0.5619 plus 0.8388. And that's just going to give me a total of 1.4 approximately kilometers across. So our crater is 1.4 kilometers across. And again, this is only one way to do this. You might decide, you might have looked at it and said, hey, this is, if I get this angle and then I'm looking for that side, I could use the cosine law. You would have then used cosine to find each of these individual sides, like we did here, and then use the cosine law to find the bottom. It just would have been an extra step because you would have done this plus the cosine law. But again, you'd get the same answer regardless of the method you use. So it's just a matter of what you see. Always look to do it in the fewest number of steps if you can. Again, saves time, and it's just we're always looking for efficiency in math. But that would be my my recommendation in that case, to use the tangent ratios. So now the next question is number 6, I believe. So we take a look at question like number 6. What we have is Lena is in a bicycle road race. In the first leg, she rides 12 kilometers from Riverside to Danton. Then she turns and rides 17 kilometers to Humberville, making a 75-degree angle from the first leg. The final turn leads back to Riverside. We want to know A, the total length of the race to the nearest kilometer, and then at what angles are the three towns situated with respect to each other. So what I've done is I've gone ahead and drawn out that situation for us. So we are here, and it doesn't really matter where you start, doesn't matter how this is, as long as you just have a triangle set up. I decided that this would be Riverside, and so she travels her 12 kilometers, and then at a 75-degree angle to that, she travels the 17, and then we're looking for the D here. So there's Danton, and his opposite side would be D. And so in part A, we're looking for the total distance of the race, so we got to find this D side. To do that, well, we have two sides and an angle contained in between them, and we're looking for that opposite side of the angle. So this is a cosine law now. So in part A, we can use the cosine law, and it would be D squared equals 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of 74. So all of that right there. And now, again, I've mentioned this before, but I recommend, if you have, as long as you have a nice good calculator that shows you what you've typed in the line above, I would recommend just typing that all in one straight go. If you want to convert that to a decimal first and then do that, that works as well. But I find that you're less likely to make arithmetic errors in the BEDMAS if you just type that in one go. So that's what I usually do. So it's just 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of 74. And that's going to leave me with d squared. And that's just a 320. And then to find d, I need to take the square root of 320. And the square root of 320 is going to be 17.9, but we're down to 18 because we're looking for the nearest kilometer in our answer. And so now the total distance, 12 plus 17 plus 18, and so we're going to get 47. 47 kilometers was her total distance traveled. Now in part B, it asked us to find these two angles. So essentially what this is doing is asking us to solve this triangle because we want to find all the information that's missing, which is the two angles and the missing side. So to find the missing angles, what I would do is, because it's a non-right triangle, I have two options. I can use the sine law or I can use the cosine law. Either one will work in this case. I do have an angle in its opposite. And then I could do this angle in its opposite. Or, again, I have all three sides now, which I can use to find, using the cosine law. Find the sine law is probably easier in this case, since we have the information. So I'm just going to do, I'm going to find h. So sine of h over h, which is 12, equals the sine of 74 over, that's not 47 down there, that's 18, over 18. Now, you'll notice if you compare that to how I wrote the formula earlier, I did a over sine A, b over sine b. It doesn't matter what's on top as long as it's all sines on top or it's all sides on top. So you can have all the angle portions on top or you can have all the side portions on top. Doesn't matter as long as it's consistent. The ratios will still be the same in the solution. So here, what I'm going to do, convert that sine 74 to a decimal. And the sine of 74 is going to give me 0.9613. And then I usually do this all in one step in the calculator. I'm just going to move that 12 over and multiply it on the other side. So I'm going to have 0.9613 divided by 18 times 12. And that's going to give me sine h equal to 0.6409. If I look that up using my table in the sine column, the closest number to that is 40 degrees. So h equals 40 degrees. And now I have 74. I got 40 degrees. And to find that last one, I'm just going to do 180 minus 74 minus 40. And that's going to give me an angle of 66 degrees here. And that's all there is to solving that triangle. Those are the two missing angles that were required in part 6b, rounded again to the nearest degree. Now, we could have, again, in part b, used the cosine law. It would work fine. You'd have your cosine A equals, and in that case, I believe we would have used, we could have used these two sides as our B and C, and then this would be our A value, and then depending on what angle you're looking for, it would just rotate around. But Sine Law, I think, is just a little bit cleaner in this case and works out nice. And the next question is it's number 7. And so number 7 here, just scroll a little bit. We got a diagram with it. We got Trevor, who is 1.5 meters tall, standing at a distance of 14 meters from a building. From his point of view, the bottom and top of the building are separated by 36 degrees, as shown. How tall is the building to the nearest tenth of a meter? Well, got the diagram over here in my notes. And so we got our 1.5, our 14, our 36. We're looking for this here. We'll call that h for the height. So we have this lower triangle. We'll kind of highlight that a little bit with some red. So down here we have this right angle triangle. Using that triangle, we can find some information for this non-right triangle at the top that could help us out. So we can use this, and we can find a missing side here, call that x. And now if I know this is x, I'm looking at maybe later on a sine law. I could use maybe a sine law, get this, and then this pair. So I'm going to need this angle too. To get that angle, well, again, I have enough information to calculate the little angle here. That's going to be 90 to the ground, so I can figure out that as well. So let's find first this side. So we'll find that missing side that we need. So we're going to do Pythagorean Theorem there. So x squared equals the a squared plus the b squared, 1.5 squared plus 14 squared. Doesn't matter the order, 1.5 and 14 or 14 and 1.5. But we'll calculate that. So we got the 15 squared plus the 14 squared. I'm just going to do it in one quick go here. Is 421 when we total that up. And then to get x, we just take that square root, and we're going to get 20.5. So we have x here at 20.5. And then I'm going to find this little angle in here. So just that little tiny angle that it looks like. We're going to find that first, and then that'll allow us to find an angle here, allowing us to find that angle, allowing us to use the sine law. So to find this little angle down here, we'll call it A. And so then we're going to find angle A using, if that's the angle, that's our opposite, that's our adjacent, tangent. So tan, and I guess I should use capital A. Tan A equals opposite over adjacent. So 1.5 divided by 14 is going to give me 0.1071. Again, you can use your calculator or you can use your table of values. We're going to get a pretty small angle here in this case, and we're going to get 10. So I'm looking at about 6. Let's say about 6. So our angle is 6 degrees. So if this A is 6 degrees, that means 90 minus 6 is going to leave me here. That's going to be 84 degrees. And if that's 84 degrees, then this angle up here is 180 minus 84 minus 36. That's going to leave me with 60 degrees up here. So I got a 60 degree angle with the x. I got a 36 degree angle with the h. And now I can just use the sine law to solve this. So I've done that Pythagorean theorem to find this little x here. I've used the tan ratio to find that little angle there, which gave me that angle, which allowed me to find that angle. And now I can use the sine law. So I'm going to have h over sine 36 equals, the x was 20.5 over sine 60. Here's my ratio. I'll look at my sines and convert those to decimals. first. So the sine of 36 degrees is going to give me 0.5878. And then 20.5, and the sine of 60 is 0.8660. So now I'm just going to take this and multiply it on the other side to find my h value, and that'll give me the height of the building. And so I'll just calculate that here, times 0.5878. And so I get the building height as to the nearest tenth of a meter at s, so 13.9 meters. So that building is 13.9 meters tall. So here, how to use a bunch of things. Sometimes you might not see it right away, and so if you just start looking at what you can find in a question, you start finding some of these different angles, find that side, look at what you can find as you're working through this, and then eventually, hopefully, what you'll do is you'll find that, oh, wait, now I have enough information for whichever formula is going to get you towards your final answer. So it takes a little bit of work sometimes to determine that. But here, again, we had the two sides of this triangle, knowing that we're going to probably need that side in that triangle for something, cosine law or sine law. Then I figured we should find that. And then to find angles, well, since we had none in this big triangle that we could find without knowing this bit of the 90, I chose to use the tangent ratio to find that, to get me that one. And then again, it was just 180 minus the other two to get that remaining angle. So that's number 7. And then our final question is number 8. And so we'll scroll back to that one. Number 8 here. We got a couple of koala bears, Rocco and Biff. And so Rocco and Biff are frolicking in a meadow, as I guess koala bears would do. And suddenly a tasty clump of eucalyptus falls to the ground. So there's a eucalyptus tree in the middle of this meadow. A clump of it just falls to the ground, catching their attention. Biff glances at Rocco, who appears to be 15 meters away. Then over to the eucalyptus, which appears to be 18 meters away. From Biff's point of view, Rocco and the eucalyptus are separated by an angle of 45 degrees. Rocco's top running speed is 1 meters per second, but Biff can run 1.5 times as fast. Can Biff beat Rocco to the eucalyptus? And then state any assumptions we are making. So for this one here, set this up for us already. So I had Biff here. He looks over at Rocco, and again, doesn't matter how you lay this triangle out, as long as you have Biff, Rocco, and the eucalyptus in some fashion of a triangle. The distance from Biff to Rocco is 15 meters. The distance from Biff to the eucalyptus is 18 meters. And the angle in between the two is 45 degrees. So there's our setup. We got Rocco running 1.0 meters per second. And Biff, his speed is Rocco's times 1.5, or 1.5 meters per second. So there's our two speeds. There's our diagram. What we need to do here is determine who's going to get there first. Well, we have enough information for Biff. He's got to go 18 meters, and he runs 1.5 meters per second. So Biff time to get there is 18. Speed divided by the time, or sorry, the distance divided by the speed. That's going to give us the time. So 18 divided by 1.5. It's going to take him 12 seconds. Now in the case of Rocco, we know how fast he goes, but we don't know how far. So we got to find out how far. So we'll call this side B. In the triangle, we got to find side B. Side B can be found using the cosine law. We have an angle in between two sides. So we'll start with the cosine law. And we'll do b squared equals 18 squared plus 15 squared minus 2 times 18 times 15 times the cosine of 45. And again, I will do that big calculation in one step using my calculator. You can do it in multiple steps if you feel that is more ideal for your learning, but I find that here we're just it's just a practice in bed mass, and sometimes takes a little extra time that we don't need to take. So I got 167.16 approximately. So b, when we take the square root of that, is going to be 12.9 meters that Rocco has to travel. So Rocco's traveling 12.9 meters at a speed of 1.5 meters per second. So Rocco time equals 12.9 divided by 1, or just 12.9 seconds. So who's going to travel faster and get there first? Well, Biff's going to beat Rocco. He's going to beat Rocco by 0.9 seconds. And the next part is asked what kind of assumptions you make. Well, in any of these realistic situations, we often have to make assumptions about things. Could be the ground in this case. They're both running on level ground. If there was any dips or humps or different types of terrain, maybe it's longer grass on Biff's side and it slows him down compared to Rocco. Things like that could be possible assumptions that we often make. So we assume that we're working in an ideal scenario. And then you can go back to the last question with the building. We're making assumptions here, that the building is not tipped or anything like that, and we're measuring the height just to the top of it, that he can see all the building, things like that. This building could be skewed over this way, and just his angle, maybe he doesn't quite see that. Maybe it's not that high and it's over here and he doesn't quite see that, the top portion or something like that. Maybe there's a tower over there that on the other side that he doesn't see. Who knows? You don't always see across the entire top of a building from the ground. So you're making assumptions in any of these realistic types of questions about where or what the terrain, what the situation is to kind of make this math feasible. Otherwise, you have to take into account a whole bunch of other factors, and we can get to some really complex math. But overall, that's the setup for it. For these questions, those are all the questions that were assigned. If you have any questions regarding these questions, feel free to send me a message on Edsby or via email. We are looking at the end of the semester now. We have report cards marks are being entered in the next day or so, and those will be submitted. If you want to know your marks, you can send me a message. I can give you what your final mark is looking like. And then again, just a reminder, as I sent out on Edsby, there is summer school. The registration deadline was last Friday, but I'm sure that if you feel you need to participate in that, either to upgrade your credit, and there are upgrade options. Those have to half the summer school time, so 10 days of learning. There is an upgrade course for the maths and English classes in grade 9, 10, and 11, and then also you could even just reach ahead and take the grade 11 course if you felt that was a benefit to you in math, English, and there's a couple others on the list there as well. Again, if you have any questions, let me know, Edsby email, and otherwise, we'll see you next year.